To finalize this part of the module, I wanted to talk to you about residual analysis. And residual analysis is the same thing when it's done in multiple linear regression. You would want to check on the assumptions and basically just to list out the assumptions. The number one is that the mean of the error term is equal to 0, that the variance of the error term is constant, sigma squared, that the error terms are normally distributed, and the fourth, that the error terms are independent. And you would want to do a couple of different graphs for in order to be able to check whether those assumptions hold or not. One of them is the residuals versus the fitted values. You would want to plot the residuals here on the scale and the fitted values on the x scale. When you do the plot function in R, you get, for instance, if your regression is named regression 1, you do plot regression 1, you get these graphs by default. So it is important that you check on them because they give you at least how the residuals versus the fitted look like, that graph looks like, how the histogram of the residuals looks like as well. So you would want to verify a few things. So first of all, the residuals versus fitted is a good graph to check whether the variance assumption, the constant variance assumption holds. If you see that there is like a funnel increasing variance as the fitted values increase, then that is an indication that that assumption doesn't hold. Also, you can check other assumptions such as the linearity assumption, and in fact R just plots something like this, and it plots like a red curve in there, showing you that this data might not behave like a linear relationship. The age and number of bits don't by themselves together they don't behave like a plane, like a linear plane. So those are things that can help you. Also, in addition to that, you get the normal QQ plot, which basically tells you the departures of normality. You want to basically check the tails and basically verify that they are not too far away from what is expected under the normal distribution. But every single regression model has to have a residual analysis, because if these conditions don't hold, then the regression is basically not valid, and basically all the assumptions that we make, all the predictions that we make can basically be very biased or inadequate predictions. All right.